Hey team, today we're going to talk about correlation. So what is correlation? It is simply a descriptive statistic that captures the relationship of two variables in one number. This is called a bivariate correlation. Bi meaning two, variate meaning variables. These are the same things. So bivariate, we can look at it in two different ways. We can visualize it with a bivariate plot. You have one variable on the x and one on the y, and you just look at the different scatter plots. Oh, I can kind of see a rough relationship there. But I want a number, a descriptive number that tells me about how this relationship goes. Now, before I go much further, I have to give you the quintessential warning with a correlation. And I'm going to write this out. Correlation equals not causation. Now, this can be said in many different ways. Correlation does not imply causation. Correlation is not causation. Oh, it sounds like you're using correlation as causation. You really can't do that. You have to remember this. This is quintessential to your understanding. This is just a simple descriptive statistic about the relationship between these two variables. It is not, one does not cause the other. And even if you did imply cause, y causes x, well, oftentimes it can be the exact opposite. So the next thing I want to talk about is the way in which we understand that. We use, for lack of a z-score. We use the z-score in the formula to help us understand it. And the z-score, if you've looked ahead, is you look at, for any record, any particular one, so we just use a little I, we compare it to the mean. And we use this fancy x bar. And then we divide it by the standard deviation for x. And remember, the standard deviation is called a sigma, or you can remember it as a sick 6. It looks like a 6, but it's kind of like sick a little bit. So I'm kind of, this is the equation for the z-score. And that's just how many standard deviations this particular record is from the mean. But what I'm going to do for this one, knowing that this is the z-score, I want it for the same one, I want to know what it is for y. This is y. Sigma for y. And then I'm actually going to multiply them all together. And then after I do that for each of the records, and then I'm going to sum them because I want to figure this all out. So I'm going to sum it for all of them. This is a little sigma, means sum them all. And then at the end, I'm going to divide it by n. Sometimes you see it over here to indicate that you do all of this first. Actually, I should do something like this. I'm going to erase that. And that kind of gives me the average of all the different standard deviation relationships throughout all of the data. And whenever we see a correlation value, a good statistical package will give me three values. It will give me a correlation number. A correlation will always be between -1 and +1. All right? This is the range. And 0 means no correlation. And the +1 means the maximum possible correlation, max. And actually, this means the maximum positive, and this is the maximum negative. So you can see that this kind of enables me to compare the different relationships of all of them because it's all bivariate comparisons, and the correlation will have any value in it between -1 and 1. Now, something that has an indirect negative means that for every time one variable goes up, the other variable goes down. Now over here, so that goes up to this. And over here for the maximum, every time the one variable goes up, the other variable goes up. And that's what a positive or negative relationship is. This is a negative where one goes up, the other one goes down. A positive relationship is when one goes up, the other one goes up. And the other thing we want to know is that the closer it gets to 0, the less the relationship. So 0 means no relationship, no correlation. And the positive one means positive relationship, and the negative one means negative. Now, it's very rare that you get something that is a 1 or a -1, unless you do something similar where you measure shoe size in centimeters to shoe size in inches. That's going to be correlated at 1. That's just a units thing. And if you ever see something correlated at that level. There's usually, you have to look for what's called multicollinearity. That's another video. But this is a scenario where, so this is the range. So, and when you see a value, you're going to get 3 values from any good statistical package, and it's going to be the correlation value, and it's going to be the n, and then the significance. The n is the number of values that determine that correlation. And that's very, very important. The higher the number, the stronger the correlation can be. And the significance, we always want to have a significance, generally with most statistical packages, is a 0.05. That's a very standard value. If it's less than 0.05, for example, like if you got a value of 0.032, well, that's less than 0.05 is considered significant. Now, in your course of being a data scientist, you want to have a significant value of 0.1. Well, that's fine. You just got to make sure that it's a little non-standard, but you have to realize you can use it. You get a little bit above 0.1, you're kind of getting into an area that the significance, the relationship is not really there. So with that, we want to have the significance. And whenever we assess correlation, we want to assess the significance first. If it's not significant, there's really no correlation. The variables have no relationship that it can be determined with that statistical test. So we look at the significance first. If it's below 0.05 or whatever your significant test is, that's a good relationship. But then we want to look at the size and sign next. Is it a big, when I say size, is it approaching 1 or -1? Does it have a lot of magnitude? Is it a strong correlation, meaning that there's actually a really strong relationship, or does it approach 0, either from the negative side or the positive? If it approaches 0, positive or negative, then we need the correlation is not very strong there. And then also the sign. Is it a positive, meaning when they both go up, they go up together, or if one goes up, the other one goes down? That's the negative. Sometimes you hear it called an inverse relationship. So we look at the significance, the size, and the sign to truly assess a correlation. And if you don't get the significant value, it's really hard to assess whether the correlation number that is calculated through this equation is actually really means anything. So we've covered what correlation is, how to find it, what variables you should expect to see, and how to assess it, significance, size, and sign. So thank you for watching. Have a great day.